presentations covering modeling, analysis, and design of water wastewater structures. And if you have not registered for the other 2 sessions, I encourage you to do so. And since this is 12th of August, we'll be covering modeling of water wastewater structures today. So let's dive right in. And my name is Kaushal Agrawal, and I will be joined by my colleague Ashwati for this presentation to cover an overview of a typical water wastewater project. We'll be introducing you to modeling templates for rectangular tanks, circular tanks, and also I will be telling you how to customize these templates as per your need. And lastly, we'll leave it to you with item and design review. So let's begin with the project overview. And in a typical life cycle of an asset, the story always begins with master planning and continues through the phase of operations and asset optimization. But please don't worry, we are not going to cover each of these phases in details, but our major focus will remain to be on structural design in these series of sessions. But let's quickly have a look at these phases and what Bentley has to offer. So starting with master planning, here I have city scale networks for water distribution and waste collection. And with these, it's easier to select the locations where we want to have the water treatment plant and the wastewater treatment plants. And one such locations has been decided over here. You can see here I have a water treatment plant, and here it is a wastewater treatment plant, and these are being shown in a larger scale images as well. So the Bentley product that can help in this process are from OpenFlows brands such as StormCAD, WaterCAD, WaterGems, SewerGems, and SewerCAD. Once these locations has been decided, the next phase is to capture the reality. And with drone images captured, we can process these images inside Bentley Context Capture, such as like these, and to generate the 3D terrain of the site. Now these 3D terrains can be edited inside the cards or the Context Capture editor and can be consumed in any of the 3D modeling applications that we have or maybe third party. So the solutions that we have for capturing the reality is of course the Context Capture, to process those drone images and the cards to edit, and the beautiful visualization that you saw was actually developed in Luminarity. Now once I have the details of the terrain, the next phase is to do the conceptual or schematic design. And in this process, we will be deciding on the locations of the parkings of the buildings, such as the aeration basin, and also on the location of the clarifiers, and giving them the height so that we can actually measure the cut and fill of the land. That's something we need to do. So here you can see a site bins developed, and we get the earth cut and earth fill volumes, and we can optimize it with this tool. So the solutions that can help in this process are OpenSite Designer, Concept Station, Access, Plantwise, and Open Plant PNIDs. Now moving on to the detail engineering after the conceptual and schematic design has been approved, we can see these whole of the plants developed, such as you can see the process starts always with the grid basin, moving on to the aeration basin, that we have few buildings over there, electrical building, blower building, and then it actually enters into the primary and secondary clarifiers. And this is actually a site of wastewater treatment plant. Similarly, we have the water treatment plant, where you can see quite a few vessels and a network of pipe which carries the water from these vessels. And all this detail engineering has been done with the help of these tools which you can see on your screen, such as Water Gems, Sewer Gems, Open Building Designer, Open Road Designer, Open Plant Modeler, and the visualization that you saw was developed in Luminarity. Now for the next phase, which is structural design and geotechnical, we have identified some of the components that we just developed in the detail engineering to be classified as structural components, such as rectangular tanks, circular tanks, or buildings. Of course, the major focus is not on buildings in these sessions, but on the rectangular tanks and the circular tanks, such as like these rectangular and the circular tanks. We'll discuss them about later in the part 2 of this presentation. And in here, you can use one of the tool or the entire portfolio for structural design and geotechnical. And moving on to the next phase of project delivery and construction, where Bentley can help with the 3D rehearsal of the construction process. As you can see, we had 4 clarifiers, and this is where we are trying to practice the way these will be constructed on the site. And this is possible with the tools such as like iTunes Services and Synchro. Moving on to the last phase of operations and our asset optimizations, we have tools which can actually forecast the demand and can be shown on the dashboard, as you can see on the screen. We can also have the tools with which you will be able to optimize the network, such as seeing the pressure and the demand at particular location with the help of WaterSight. And here is an example with which we are trying to visualize the contamination of water and the effects of it in the nearby area with the help of WaterOps. So the tools with which it is possible are AssetWise, WaterSight, and WaterOps. And whole of these data can be very well managed by the ProjectWise. This is just a short overview of a typical water wastewater project and how Bentley can handle it. Now, before we go further, I'd like to have one poll question to understand if you are working in water and wastewater industry. So please record your answer in the pop-up dialog box that might have opened. The pop-up dialog box will remain open for 30 seconds. So please be patient and record your answer. Let's enjoy the part 2 now. Now, before I take you to the templates for rectangular tanks and circular tanks, it's important to answer one question here, is if we can reuse the tanks that has been modeled in the phase of detail engineering. So the answer is yes, but let's look at the process very, very quickly. So here what you saw is the wastewater treatment plant, and this is the original model. And let me focus here on the aeration basin, which is actually a rectangular tank with some compartments, and here it has been actually modeled. And it has 4 channels. Let me focus on one of them. And if I get rid of all the non-structural components, I will end up with a model something like this. Now the task here is if we can transfer directly this model inside STAAD Pro. Now that's possible with the help of iTwin Analytical Synchronizer. So this is a map which maps all the products which can transfer the geometry to and fro. So here, most of the model that we saw in the detail engineering phase has been developed by Open Building Designer or ProStructures, and both are being supported over here. So we can transfer the geometry to iTwin Analytical Synchronizer, and then in turn it can be transferred back to STAAD Pro. Please also know that iTwin Analytical Synchronizer supports few third-party applications as well, as you can see over here. So let's understand this process very, very quickly. So this is where I had the model, and I'll go to the file and say export to ISM, creating the repository and choosing all what I can see on my screen from view number 1 and say OK. So the synchronizer will open, which will let me choose if I want to transfer all of the geometry or let's say few of the elements only to the repository. At this point of time, I'll select all and say accept and update the repository with all of the elements. And the data has been exported successfully. I'll save the file. And now let me open that file inside the synchronizer to show you what has been transferred. So this is the same model that we had in ProStructures. And if we click on any of the elements, I can see all the properties have been successfully transferred to the synchronizer file. Now let's take this inside STAAD Pro physical model. Please note that with physical model, it's now possible to transfer the plate elements. So I'm going to say select File, ISM, and iTwin Services. And here I have the synchronizer. It's from my local machine. So I'll select that file that I've generated from the ProStructure and click on Next. The synchronizer will give me two options to pull or push the changes. At this point of time, I want to pull the changes. So let's select on that. And again, the synchronizer will open and let me choose if I want to transfer all of the geometry or few of the elements only. At this point of time, again, I'll say select all and accept. And here you see the same model that I had in the detail engineering phase transferred to STAAD Pro for analysis and design. I can also have a look at the analysis model here in the 3D view itself to see the meshing. Looks pretty okay to me. And then if I want, I can even transfer this model to the analytical modeling. So let's click on the model, analytical modeling. And based on the number of elements, it will take a bit of time. And here you can see the model has been transferred to the analytical modeling. Now you can model the loads inside this model to take it to analysis phase. You can do that inside physical modeler or analytical modeler. But as we understand by the user feedback, that if in case of a revision, the application of hydrostatic load can be very, very tricky and can take little bit of a time. So we have come up with a rectangular tank template, which will be shown by my colleague Ashwati here.
Another option to create a rectangular water tank inside STAAD Pro will be to use the structure wizard option. So in the latest version of STAAD Pro Connect Edition, we have implemented a new feature called structure wizard. In the structure wizard, you will have some predefined templates of rectangular water tank. And this can be used to create your own water tanks. So let's see what we have here in the structure wizard. So you can see we have two templates already available for water tank in here. One is a physical tank and another is an RCDC tank. Physical tank, as the name suggests, has continuous walls and slabs. In the sense, the walls along the length will be continuous for this rectangular tank, and the same will apply to the slabs also. In the RCDC tank, the walls and slabs will be discrete or discontinuous. That means the walls will be split at the junctions of the interior wall, and similarly the slabs will also be split. In this exercise, we will be using the RCDC template so that later on we can design this tank in the RCDC module. And in this template, we have three options like geometry, supports, and loading. So let's see how we can modify the geometry in here. So currently the tank has two compartments. You can change it to any number, say 4. And you can also change the thickness of the base slab and the total length of the tank. So let's say it is 28 meter, which is same as the tank that we have seen earlier. And you can also change the total width, toe to edge of walls and then height of the walls, and the thickness of the outer and separator walls. There is also an option to have columns inside the compartments. So you can have more than one column inside the compartments, and you can specify the number here. Then you can also specify the dimensions of these columns and the beams associated with this. The tank material will be concrete here, so you can select that. Then you can also include a roof slab over the tank. So once you click that, you can see a slab will be generated over the tank, and you can define the thickness of these slabs as well. And you can specify if it is a simply supported slab. You can have a pile below the columns, and that option is there. And for base slab, you can either have a soil support or pile support. Since I have selected the soil support, you can see the soil springs generated below the base slab, and then you can enter the soil properties like the soil stiffness and the subgrade modulus. And then comes the loading part. So you can define the loads as load groups or load cases. If you are defining it under load group, the loads will be transferred as reference loads in the analytical modeler. And since we have defined the roof slab, you can enter the roof surcharge and the roof live in here. And then you can enter the fluid density or the water density in here. The next option that we have is the compartment fluid height. So here you can see we have 4 compartments, so you can enter 4 compartment fluid heights here. You also have the option to enter different fluid heights in these compartments. So since I have 4 compartments, I have entered 3.75 in the first 2 compartments and 3.25 in the next 2 compartments. And based on these fluid heights, the program will generate the hydrostatic pressure inside this compartments, and also it will calculate the base pressure at the slab. So you can see now the program has generated the dead loads, roof loads, as well as the hydrostatic pressures at these compartments. So compartment 1, 2, 3 and 4, it has calculated the hydrostatic pressures. And once we are okay with this model, you can save this and transfer it to the physical modeler. Before doing that, let's see some important features here. So you can see that the current template that we have cannot be edited. You can see some lock symbols near to this. That means you cannot edit these. But what we can do is, you can make a copy of this template, and these copies will actually can be edited. So let's name this template, and these are basically XML template. You can edit this template to create your own templates. So you can have custom templates by changing the XML templates. So once you hover your mouse over here, you can see where these templates will be located. So let's see how you can edit this template. So this XML template is for the RCDC tank, and if you want, you can add more features or create your own structures using this XML template. So this is a very powerful feature of this template. So what I have done here is, using this edit feature, I have created a new template where I have added an option to add soil pressure loading onto the water tank. Currently this option is not available in the template that we are providing. So I have tubed the code and then added this option. So I have uploaded this file in the communities. So I'll show you where you can get this templates. So in the STAAD communities, there is a new segment called the files, and once you click on the files, there is a page called STAAD API solutions, and in this you will have a number of API solutions. It can be XML templates or some OpenSTAAD files, and the first one you see here is the rectangular tank template with soil pressure loading. Make sure that you are signed into the communities to download these files. So let's go ahead and download this tank template with soil pressure loading. And this is a zip file, so just unzip this once, and you can see that this is an XML file. So let's see how you can transfer this XML file in the physical modeler. So let's open our STAAD Pro again. Here let's create a new custom folder, and then we will import this XML template that we just downloaded in here. Let's give it some name as custom, and then we'll try to add our XML template here. So it will be in our downloads. So at any point of time you can exclude these templates from the physical modeler tree, and you can also include them. So these custom templates will be by default stored in the app data folder in the C drive. So you can see the new template that I just created is available in here. So you can include or exclude these templates at any point. So let's go ahead and see how the soil loading has been generated in this new template. So the rest of the values will be the same, but we have an option called soil pressure in here. Once you activate the soil pressure, include soil pressure option, you will have two conditions. One is a dry soil condition, another is a submerged soil conditions. For the dry soil conditions, you can enter the soil height and the earth pressure coefficient and the dry soil density, and based on these values the program will calculate the lateral earth pressure and apply onto the exterior walls of the tank. And the next condition that we have is the submerged one. In submerged case we have two conditions. One is the partially submerged case and then another is the fully submerged case. So for the fully submerged case, the height of the soil and the groundwater table will remain the same, and you can enter the water density and the submerged soil density, and based on these two values the program will calculate the lateral earth pressure. And for the partially submerged case, you can enter a different groundwater table. So here the height of the soil is 4 meter and groundwater table is 2 meter, and it's a partially submerged condition. And here you have to enter the soil density above the groundwater table and also the submerged soil density and the water density for calculating the lateral earth pressure, and then the program will apply it onto the exterior walls. So once we are okay with this soil pressure and the other loadings that we have applied, you can save the file and transfer it. So you can use a reference point to transfer this template to physical modeler and say okay, and you can see here the template has been successfully transferred to the physical modeler. Let's have a look at the 3D view, and this is how the 3D rendering has been done in the physical modeler. Here you can see that there are different levels at this wall. So there is a 2 meter level which is the groundwater table level, and you have a 4 meter level that is for the soil height, and then there is a water height inside the compartment. So while meshing these surfaces, you actually have to take care of all these levels, right? So in here, the program will automatically mesh these surfaces, and all these levels will be taken care while doing the mesh, and also the connection between the walls and the slabs will also be taken care of during the meshing. So that is again another powerful feature that we have in the physical modeler. You do not have to manually mesh anything, but the program will do that. So let's select all these surfaces and provide a mesh size here, and then the program will mesh these surfaces. So now after providing the mesh size, let's have a look at the analysis model and see how the meshing has been done by the program. Okay, the meshing is completed, and you can see it has taken care of all the levels at the top, at the 3.75 meter level and the 4 meter levels, and it has also connected beautifully with the slabs and the walls. So once you are okay with the meshing done by the program, you can review the loadings generated by the template. So currently we have generated the fluid inside the 4 compartments and also one soil pressure, right? So let's have a look at these hydrostatic loads in compartment 1, and then there will be a base pressure also, then for compartment 2, 3 and 4 and so on, and there will also be a soil pressure generated at the exterior walls. So that is also available now. These are all the loads generated by the template, but if you want to add your own loads, you can enter it under load group separately in here, or you can also use the load cases option. You can enter it directly, or you can enter it through a spreadsheet option. So here you have a spreadsheet option for entering the load cases. I have already created an Excel sheet with various load cases, so I'll just paste the data that I already have. Let us just review these various load cases in the GUI. So I have created some cases where we will have fluid in compartment 1, 2 and 1, 2, 3, 1, 2, 3, 4. These are all the load cases that you will find in a real life water tank. There might be other conditions as well, but for the time being I have added these cases in the water tank. And similarly you can create load combinations, and load combinations can also be created using this spreadsheet option. So I already have some combinations generated in an Excel sheet. I'm just copy pasting it here. So this one also we can review it in the GUI once, and you can see the various combinations: dead load plus soil load plus fluid load. And once you are okay with this load combinations and the load cases that we have generated, we can take our model into STAAD Pro Analytical Modeler. So before doing that, let's add some analysis command in here. So currently we have implemented this analysis command also inside the physical modeler. So we have various analysis type currently, like the linear elastic, P delta, everything. So let's go ahead with the linear elastic analysis, and you can select the load cases that you want to consider. So I'm selecting all the load cases that I have generated, and then I will take this model to the analytical modeling interface. So let's click onto the return to analytical modeling interface, and it will create an analytical model now. Since our model has a lot of plate elements and we have given a fine mesh, it may take some time. So it's creating the surfaces and the supports. So it's almost done. And the analytical model creation is successful. Let's say OK. And the model will now be transferred to the analytical modeling interface. So here you can review the properties like the plate thickness that are assigned in the physical modeler and the supports that we have assigned. So you can check that we have assigned a plate mat here. And then the important part is to verify the loadings that we have generated. So we have generated some load groups in physical modeler that will be transferred as reference loads here. So we have the hydrostatic loading in the various compartments. So in compartment 1, we have a trapezoidal load, and we have the same hydrostatic loads in compartment 2, 3, and so on. And also we have applied a lateral earth pressure, and since it's a submerged condition, the program has calculated the buoyant pressure at the base of the slabs, and then you can review the earth pressure loading at the walls. So all these can be reviewed, and then we have the load cases and the load combinations that we have generated. You can check these values, and once you are okay with this, we can go ahead and run the analysis. So the perform analysis command has been already added from the physical modeler. We can just go ahead and run the analysis.
I have one more question for all of you. Do you think the tank visual that you just saw in the physical modeler would add value to your day-to-day work? And we'd like to know your feedback. This will encourage our development team and us so that we'll do this and continue to do this work for water and wastewater industry. So please record your answer if you think the visual that you just saw will add value. I have one more question to ask over here. Is that, do you think what are other modeling templates would be useful for you? So apart from what you saw today, if you think that there is something else which we can include as part of the template, we'll love to do that. But please let us know that which of the templates that you may need for water wastewater industry. And we love to add that as part of the physical modeler template. Great. So let's enjoy the last and third part of this session. Now let's come to the circular tank or clarifier template. So what we have done is we have published this template on Bentley Communities. And please note that the location which I'm going to access now on my web, it's also provided in the resource list. So I'm going to RAM and STAAD forum, and inside that RAM and STAAD API solutions. And in here, I can find among all of these amazing tools, there's one tool called STAAD Clarifier Modeling Tool. So let's click on that. Now, it's important that you should be signed in to Communities to be able to see this download button. And here you can see some of the features have been mentioned, such as you have much better control over the mesh generation process. You should be able to model launder, support columns, and different part of the clarifier will be automatically added to the groups so that application of the properties and the loading will be much more easier. There's a tip as well and how to configure steps. I've also provided a help document if you need that, so you can download this. So what I'm going to do right now, just to show you this, let me download this. It's gonna go inside my downloads folder. And let me open its location. So here you can see it's a version 2.2 right now, which is the current version. And I'm going to configure it inside my STAAD Pro. So here I have an empty file opened inside STAAD Pro. And I'm going to go to Utilities. And in here, I'm going to say User Tools and Configure. So let's click on that. And I'll say New. I'm going to name it as Clarifier Modeling Tool. And in the command, I'm going to browse to the location where I have just downloaded the Clarifier Modeling Tool version 2.2. So let's click on Open and say OK. So as you've done that step, you should be able to see the user tools right now here. So let's click on this. And we can see that I have a form in which I need to provide some parameters. So please note that on the left-hand side, you have the main parameters, and on the right-hand side, you have to provide the divisions, so number of divisions that you want for the same parameters. And these are grouped as per the component of that particular clarifier. So first of all, the base slab, outer diameter, sum diameter, and the divisions that you want along the circumference and along the radius. So I'm going to provide 25 meter outer radius, and the number of divisions will be 144, let's say. Number of divisions along the radius, I'm going to provide 20. The depth of circumference and depth of center. So we have provided the flexibility to the user in case you have flat slab. So you can have similar depth at the circumference and at the center. But in case if you have an inclined slab, so that you can provide a different height. In case of walls, we have given another option, which is you can have equal divisions of the wall, along the wall height, or you can define your own divisions, just in case if you have to match it up with a water height or maybe a soil height, so you can do that. Similarly, in the footing wall as well, when you're defining the depth, the divisions across the footing wall has similar options. The heel and the toe of the footing has been mentioned over here. Then in sump, you have an option to have a closed sump with no central column modeled, or by default it is being modeled. Okay. And the modeling of launder is also optional. So at this point of time, I'm going to model the launder. And I think I provided all the parameters as I want it to be. So once we are happy with our input, let's click on OK, and the program will start to run. First of all, it's gonna model the base slab, and once the base slab has been modeled, it will select all the elements which are part of the base slab and will add them as a group. So that process is going on. And here we go, it has been added as a group, and now the walls have been started to model. And here in this case, we have selected the equal divisions, but as I told you that you have the flexibility of choosing these divisions by your own, so you have both the options available. And then the launder slab and the wall has been modeled. Then again, footing wall provides a similar option as the tank wall. And then the heel of the tank wall has been modeled, and then the toe. Please know that each and every part of this clarifier will be added in a separate group, so you should be able to select that. There is one more thing which is very, very important, is that if you keep on looking at the screen, it may take a bit of a time to model the entire clarifier. But if you minimize this window, it will barely take about 10 to 20 seconds to model the entire structure. Because in that case, it will not have to update the view after each and every operation. And hence, you see the clarifier has been completed. So here at few things I want your attention. First of all, as you can see, as the radius is getting smaller, we have coded an intelligent way of managing these plates. So you can see that we have some triangular plates over here so that the size can be managed, and still we have very good connectivity with the plates on the base slab and plates on the sump wall. Please also know that if I show you the plate orientations, all plate orientations are in the same direction. So when you apply the load, there will be no discrepancy in that, and when you extract the results as well, there will be no discrepancy in that as well. One of the other things that you might have noticed that it is an inclined slab, as we have given the input based on that. And if you want to have a look at the 3D view, here you can see that you have this 3D view available, where you can see the launders, the support column, and the sump wall and slab, and this support column being supported at the end by the foundation. All that has been modeled with just one click. Now, one of the other things which I keep on saying is that each and every part will be added to the group. So let's review that. So let's go to Utilities and Groups. And here I can see that I have a lot of groups. So let's select one of them. Let's say base slab and highlight. You can see that all the elements have been added to base slab. Then if I select tank wall, launder, footing wall, footing heel, footing toe, sump wall, sump slab, support column, and then we have the column foundation. So all that has been added to the group. So it's now easier to apply the properties to them and as well as the loading. So this is what we have done at this point of time. Of course, I understand that we may want extension of this facility towards auto application of properties and as well as the hydrostatic loading. And I can say that yes, we are working in that direction as well. So we'll soon hear updates on the communities itself, that a new version will be released of this clarifier, which will have all those facilities. But in case if you need anything else, please, of course, let us know, and we'll try to include as soon as we can. Now, just to reconfirm that from the same clarifier modeling tool, you can model a full structure which will have the launder, the support column, the foundation, and with the base slab being inclined. Or in case if you need a smaller, cleaner model, such as like this, with no launder, maybe the flat bottom slab with no support column, it's possible to do that. So the same modeling tool can produce this and can produce this as well. Moving on to the last part of the presentation, we earlier saw that how iTwin Analytical Synchronizer can help in reducing our task of remodeling. But let's understand that how iTwin Design Review can help us in our workflows. So basically, you should be able to review your model on the cloud with iTwin Design Review. And when I say on the cloud, you're going to open a browser tab. So basically, whatever the device you have, if you have a browser on it, should be able to review it. You have the option, and I like to emphasize on the fact that it's an option to invite external members as viewers as well. You can easily collaborate with your project members. You can comment on the model, and as soon as you comment, they will be notified that a comment has been made with their name mentioned in the comment. So it will be a quick way to resolve all the issues in your model. And lastly, which is the most important thing, it keeps a record of all the comments that you might have done on the model. Here is a sample. You can see that the model with which we've been working, which is the rectangular tank model, we can open that on a browser tab and the design iTunes design review and can comment on it. I can include a member in the comment so that he'll be notified that a comment has been made so that he can react quickly. So let's see this in action very quickly. iTunes services can be accessed via physical modeler, and in here I have the option to go for iTunes design review. Once I click on it, it'll ask me to sign in and go for the authentication. Once I've completed that process, they'll ask me to create a new session. So I'll create a new session and give it necessary tags so that it'll be easier for me to filter it afterwards. I'll add one of my colleagues and click on next. Once it is successfully created, I can click on its name and should be able to view it on a browser tab. And in here, you'll see that the same model that I've had in my physical modeler is available to me for review on the cloud on a browser tab. And here I have all the information that I would need to review it, such as all the fixities, the nodes, the supports, and the concrete properties for the slab and the beams and the columns. I can hide few elements if I want to, or I can comment on such elements where I have a doubt whether those should be included in the model or not. So in this case, asking my colleague if we have these columns or not. Soon as that comment has been made, Abhishek has been alerted that Kaushal has made his comment, and he has replied that, yes, please go ahead. And just for his knowledge that I've received his comment, I'll comment back. So one such issue is easily resolved. You can also export these comments in an Excel sheet, so you have all the record that you may want. And with this, we would like to conclude our session for today. We hope you enjoyed it. There are various ways to be connected with us on Bentley Communities. You can also follow along on our YouTube channel. You can search it with Bentley Structural. You can also follow us on social medias. There is a toll-free number here as well for the support. And I really thank you for attendance. Thanks. I have few poll questions for you. So one of the question that I like to ask is, after looking at the clarifier modeling tool, do you think that adds value to your day-to-day work? Please record your answer. That will again help us to improve the tool. If you think that it adds value, we would even encourage you to file in the survey if what enhancements you will need or you would like to have in clarifier modeling tool so that we can include it in future releases. Lastly, I have one question. If you think that by looking at the presentation, you would need some help, you want to be contacted by sales representative for Bentley Systems, please record your answer. We will contact you for any query that you might have. And we'll be tweaking some questions now. Though our colleagues who are managing the Q&A relentlessly been looking at your questions that we are receiving regularly and trying to answer. Please know that some of your questions will need even a bit of a time from our side. So we will definitely respond to them, but that will be a bit delayed and maybe an email response, and not all will be addressed live here. So one of the question that I like to take is, which is very common, almost everyone is asking about it, regarding the the hydrodynamic pressure. So please stay tuned to the second session in this series, where we are going to show that how you can add how you can apply easily with the use of a template the hydrodynamic load on these kind of tanks. So it's already included. We have already thought about it, and we have developed a template for it. And I like you to stay tuned for the second session in this series for that, and we'll definitely be covering those topics. There's one more question which keeps on coming, is where I can see this video again. Please know that all these sessions are recorded. So once the live webcast is over, the recording will be available approximately 1 day. So that means by tomorrow you will see this recording will be available, and you will be able to access that recording with the same link with which you joined this session. Okay, so no worries if you have missed anything. You can watch it one more time or as many as times as you want with the help of the recording. Okay, we are getting questions, a lot of questions. Ashwati, would you like to take one question? Is how to model tapered walls?
Yeah. So currently the tapered wall option is not available in the template that we have presented, but we will be implementing it in the next release. So in the next release of STAAD Pro Connect Edition, you will have the tapered walls available.
Thanks for that. Okay, most of the questions which we are receiving regarding the dynamic water pressure, it is actually good to know that it's one of the topics that you like to see. As I said, it will be taken up in the second session in this series, which will air live on 26th of August. Please stay tuned with us, and we'll be definitely covering the hydrodynamic load, how to do that. Okay, I'm getting one question which is intriguing. Does overburden pressure will be considered for wall foundation design in clarifier tank? Please know that at this point of time, the clarifier tank template is helping only at the time of modeling. it is not been extended yet for the application of the loads. It will be extended as per as we are receiving the feedbacks in which direction it needs to go. At this point of time, there are various situations, considering the various situations with which our users need to go. We try to create a tank template which can cover most of the circular tank that we do in real life. That was the original purpose, but yes, we are getting a lot of requests of extending it further, and we'll be taking that request very soon, and we'll be releasing a new version on the Bentley communities. Please know one more time that both of the templates that we have shown, one of the custom template for soil pressure load for rectangular tank and the clarifier tank template, both are available on Bentley communities, and the link has been provided in the resource list. So you should be able to get it and go there. And if you're signed into connection communities, you should be able to get it. Okay, one of the other question which we are receiving quite a number of time is from which version this template has started to come in. Please know that the physical modeling visual that you saw today has started to come from V22 version update 5, but the latest version is V22 update 7, that is STAAD Pro V22 update 7, and it is recommended that you use the latest version for using those templates. For doing this presentation, we all been using the update 7. So what you saw today will be, of course, available inside the V22 update 7. Please also know, I should clear this doubt as well. If you are under Select subscription, there is no additional fee for upgrading the software. You should be able to go and sign in and download the software, the latest version, and install it in your machines. So with Select subscription, all the upgrades with the latest version are free. Okay. We are receiving some of the questions which even will take a bit of a time from our side to answer. So I'm skipping those questions at this point of time so that we can answer them in details. If necessary, we'll provide some screenshots as well to answer those questions. So please don't worry about that. We have missed your question. We are recording all your questions and we'll definitely be answering all of those. One of the question has been asked, what about irregular shape of rectangular tank? Need to understand what kind of irregular shape we are looking for. But please know that what my colleague Ashwati tried to show is that the template that we've been releasing inside the physical modeler, those are all customizable. So basically, if you know a bit of a logic, which I understand all engineers know, then you should be able to edit it and customize it to suit your requirements. It's very easy. It's an XML file. So as far as I understand, it will be a piece of a cake for most of the engineers here to amend it, to edit it, and to suit your own requirement. Okay, we are still receiving a lot of questions. yes, I'm keep on saying for some of the questions we will need some time to even answer. Please don't worry about that. We'll definitely be answering your questions if needed via email for sure. There are some questions being asked regarding the code that is being support. Please know that that we'll be covering the design aspect of these tanks in the third session of this series, which will air live on 9th of September. So I think I'll encourage all of you to be there to see what can be done as far as the design is concerned. And the second session will be on the seismic events and covering the hydrodynamic load application on these tanks. Yeah, there is a very interesting question which is coming in. Similar to rectangular tanks with compartments, can we model RCC caissons of defined size having filled with approved soil or other approved filling material inside compartments? Basically, what I wanted to say is that the template that we have shown is totally customizable. You can even write it from scratch, or if you want to edit it, you should be able to do it. There is no way of stopping it to you. And as I said again, the logics are pretty simple. If you are an engineer, as far as I understand, should be able to edit it and suit it to your requirements. If your requirements are quite general, then we'll love to take it upon us. Are very specific. We'll like you to edit. And if you need help, we'll be there for sure. Okay, we covered a lot of questions, and but we understand that some of them has been skipped because, as I understand, answering them here would not be possible. We'll definitely be doing it via email. We are receiving some feedbacks as well. Thanks for that. We'll be taking that. We'll be taking care of that in the next session. And I think it is time that I should end this webcast. I know I'm thrilled to see the response that it's really overwhelming, and I think we'll definitely make sure that some of the requirements which has come as in general basis will be fulfilled by our development team. We'll be taking this feedback and we'll be passing on to our development team for sure. So thanks for your participation, and see you next time on 26th of August, the second session in this series. Please stay tuned with us. Thank you. Bye-bye.